In this episode, we're going to clean up the code that we wrote in the first episode, link in the description. All of our code is essentially living at the top level of the module, essentially global namespace, as close as you can get to it in Python. We're just going to put the existing code in a main function. Write the word main, indent the existing code. Now, it says we've got 2 errors now, so let's look at what they are. Buffer is not defined. All right, this, by pure fluke, is an excellent example of why you probably shouldn't put code in the global namespace. If we undo the changes we made, the error goes away because this buffer exists in the global namespace. So inside of this function, it's there to be deleted. When we put this code in a function, I wrote data here, but I didn't change this to data. This should have been data, but now there's a type error because readable buffer doesn't define delete item. The only reason that this worked in the previous episode is because I was passing buffer to this function, so data and buffer ended up being the same object. So let's just fix that. The type of this should be byte array. And let's put this back in a main. And now we have no errors. Test that it still works. Good. We want to pick apart this big blob of deeply nested code. This chunk of code here and this chunk of code here is purely about managing this bad blocks subprocess, and it's not actually to do with the business logic of how we pass the status out of bad blocks output. So when you see a chunk of setup code and then a chunk of cleanup code with unrelated code in the middle, that's where you want a context manager. The bit where you would have your unrelated code, you write yield the thing you want to yield, which in this case is std. We don't have args here, so let's pass in the output path. The return type of the context manager is going to be a generator, and it's going to yield a IO bytes. Let's use our context manager here. So we now do with open bad blocks args bad blocks as std. And hopefully that should work exactly the same. Yep, that still seems to work. The code that renders the output table is here and here. Let's clean that up a bit with another context manager. So this context manager is a little different. We are yielding a callback that lets you do the update. And the return type of our context manager implementation is a generator that yields a callable that takes a status and returns none. Which is that. Check that that works. Yeah, still looks good. For aesthetics, I'm just going to move that to the outside. So this chunk of code here is all related to efficiently reading chunks of data from the std. That can all be put into an iterator. Inside of this iterator, there's an infinite loop that ends when data comes back as being the empty byte string. This code here is all about extracting the statuses that are in the buffer. So we can do a similar sort of trick that we did for read data and create an iterator. Pop statuses returns an iterator that goes through the buffer, extracting out as many statuses as it can. And the iterator stops when there's no more statuses currently in the buffer. I'm going to rename this to pop status just to match with pop statuses. We don't need that loop anymore. Let's see if that still runs. Looks good to me. We've broken down that big clump of code into 4 separate chunks: open bad blocks, open table, read data, and pop statuses, which has made the main loop of the project really easy to understand. We start the bad blocks process, we create a live updating table, we loop through the stud out, getting the chunks of data, we add those chunks of data to a buffer, we go through the buffer, removing any statuses that we find, and then we update the table. That'll cover it for this episode. In the next episode, I think we're going to put a proper command line interface on this utility.